So, reflecting on the last two presentations, I find myself wondering if ecosystems and emerging materials can teach us about intelligence, so can the Earth itself. To open that thread, I'd like to invite Professor Niki Evelpidou of the Department of Geology and Geoenvironment at the National and Kapodistrian University of Athens to the stage. Niki, the floor is yours.
Thank you very much. It's a great pleasure for me to be here with you today and share with you ideas about decoding Earth's intelligence in order to design the future. Coastlines are facing huge pressure nowadays. 50% of the world's sandy beaches will be close to extinction by the end of our century. And this causes serious problems in the environment, in the infrastructure, and in the economy of the local areas. It is not a problem that we are expecting to come. It is already here. You may have a look to the left picture, how this beach, it is a sea beach, one of the most famous and touristically exploding beaches in Kefalonia Island, how it used to be in 2011 and how it was about a decade later. And this is how it looks like today. And of course, it is not only about our beaches. It is also about our cultural heritage that suffers from coastal erosion. And the problem becomes even bigger because of the climate crisis that pressures even more the coastal zone. Why? Mainly because larger and more intense waves approach the shoreline and erode the beaches. And this is how we react as a human community to this problem. In order to mitigate coastal erosion, we mainly have two ways to mitigate. The one is based on hard engineering. It includes a lot of cement, which one of the big problems is that it leaves an important footprint to the environment because of the carbon dioxide. And the other one is the soft engineering, mainly beach nourishment, that transfers the problem to another site. This is the answer of the nature. The nature protects our coastline, creating reefs that act as breakwaters. Of course, it takes some thousands of years to create something like that, and then it stays there, and it protects the beach for 1,000 years without any maintenance. And also, it provides a very beautiful environment. So, mimicking the process of the nature, we activate bacteria, transforming seabed material into reefs that act as breakwaters. In fact, we do what nature is doing anyway, but we speed up. So it takes for us a few weeks to do that. The implementation includes only materials from the seabed and local bacteria. No foreign material, no raw materials foreign to the site of the implementation. Our hundreds of experiments shows that all types of seabed sediments can be biocemented, and also the mechanical and geochemical and mineralogical characteristics are identical to beach rocks, which is their analog. So, some of the advantages, except of protecting the beaches from the erosion. It's environmental friendly solution. It needs no maintenance, no impact on coastal zone activities, and it helps the revitalization of flora and fauna. Last but not the least, it reduces the carbon dioxide of the environment. How it happens? Because bacteria, through their biological activity, they absorb carbon dioxide from the environment and precipitate with carbonates. And this carbonates is the natural cement that, in fact, bounding the loose material and provides a biocementation. Just to give you an idea, in order to protect 1 kilometer of coastline, it's like we are taking off 750 cars for 1 year. Nature knows. Our challenge is not to invent every solution from the scratch, but to learn how to read the wisdom that it is already written in the landscape, in the ecosystem, in the natural process. Let's try to decode what the intelligence of the Earth, to work with the nature in order to design a resilient future. Thank you very much.